Welcome. This is task 4 of email spam detection. First of all, I'm importing all the essential libraries and reading the file. The essential files that are required, libraries that are required is pandas, py, matplotlib, cbon from sklearn.preprocessing. I'm importing label encoder from model selection. I'm importing train test split, feature extraction.txt. I'm importing count vectorizer from tree. I'm importing decision tree classifier from naive base. I'm importing multinomial naive base. Then from metrics, I'm importing accuracy score, confusion matrix, classification report, mean absolute error, mean squared error. First of all, I'm reading the CSV file. Since the file was encoded, so I've used the encoding of Latin 1. Then I've checked the head of the data frame, where I found that unnamed 2, unnamed 3, and unnamed 4 are columns with no values. So on pre-processing, I've removed those columns, which is unnamed 2, unnamed 3, and unnamed. Further, I've also seen that V2 and V1 should not be named as such. Okay. Instead of V1, I've the taken the name of the column as spam. Since we are over here, we are detecting whether here we are detecting whether the message is or the email is spam or not spam. And V2 specifies the message. Then going on to the exploratory data analysis, I'm checking the basic information about the dataset. Both the columns are object and contains no null values. Then I'm seeing the mathematical orientation of the dataset, and I found that in spam column, the top messages or messages which have been classified as ham, and the frequency of ham messages are 4825. In message column, sorry, I'll call later is the most occurring or the top occurring messages with a frequency of 30. Then I'm checking the null value, again checking with the duplicate values. When I ran duplicate values, I got a duplication of 403 rows. Then dealing with the duplicate values, I've dropped those duplicate values and saved it into the same data frame. Then going on to the data visualization, this data visualization talks about the percentage of the spam to ham messages. So 87% of the emails are ham, which is not spam, and 12% of the data is spam. Further, going on to the bar graph of unique words present. So here I'm going to the column of df.messages and applying a lambda function onto it, where the lambda function gets all the unique length of the unique words present in the message. Then I'm counting the number of length of each messages and plotting it onto the graph. Next, I'm selecting the model for training and testing. So py reports to my spam column, whereas message columns is refers to my training or the input columns. Then I'm splitting the data into train, test, where x train, x test, y train, y test. I'm splitting the data where the test size is 20% of the entire data set. Since the output column, which is spam column, should be encoded in a numerical form, I have used label encoder to transform that data. So here I'm fitting and transforming the data of spam and ham. So spam will get 1 and ham will get. Then I'm performing model pre-processing. In this, I am transforming the text. Since the input column consists of only text, I'm converting that text into a frequency of count, or the text is converted into a vector based on frequency of each occurring text words. So basically it counts the unique words on to the text. Then I'm fitting and transforming it to the x test, x train of the messages and x test of the messages. Then I'm training two models over here. First is the decision tree classifier, and second is the multinomial naive Bayes. Then I'm predicting the value of the classifier, which is done by the decision tree, and also with the multinomial naive Bayes. On model testing, the classification report on the y-test to the y-pred decision trees is as follows, where the precision recall remains the same for 0, which is ham messages, and spam messages, the precision and recall is 0.89 and 0.86 as follows. The overall accuracy gained by the decision trees is 0.97. In this, here I have made a matrix, or also known as confusion matrix, to see what are the data, or what is the data present with us. So this becomes 870 and 120. So on calculating the mean absolute error, mean squared error, and root mean squared error, errors are very less in the model, but it tries to overfit the model. So it's better to check onto the different model. So that's why I've imported multinomial naive Bayes classification. Here the accuracy jumps on to 99% with a precision score of 99 and recall of 1. After drawing the confusion matrix, I found that 890 and 130, a slight improvement in the error also means the error is much lesser than that of a decision tree. So on comparing the two models, I can say that multinomial naive Bayes perform much better than decision trees. Thank you.